Okay. All right. So let's start with what we know. We know that when we're doing like y equals sine of x is an angle, right? Okay, and y is whatever the sine ratio is, correct? Okay, so what we're going to be talking about today are inverse trig functions. Anybody know what an inverse function is? From I think algebra 1. And what does it mean to be an inverse? Perfect. Okay, inverse functions just means that the x's become the y's and the y's become the x's. So the inverse function, Madeline, quit laughing at me, okay, would be x equals the sine of y. Okay? The inverse function of y equals sine x would just be x equals sine y. Okay? So now, x, which is the input, would be the sine ratio, right? And y would be, actually the x would be the sine ratio, and y is the angle measurement, right? Okay, if I want to write this in functional form, meaning a y equals form, instead of saying x equals sine y, I would say this. Y equals the inverse sine of x. Okay? Great, you want to get this down. Or, I could write it like this. Y equals the arc sine of x. Okay? These two things mean the exact same thing. Let me say that again. It does not matter whether I call it y equals the sine inverse of x or y equals the arc sine of x. They mean the same thing. Like when we put this -1, that means the inverse of for anything. But when we say arc sine, that's kind of unique to trigonometric functions. That's the only time you see that. But what you need to know is they mean the same thing. Okay? Everybody good with that? All right, now, when we said this originally, when we said y equals sine x up here, okay, you take the sine of an angle, right? So the x was the angle, and the y was the sine ratio. Right? So think about this, because this is the part that I think is kind of tricky. Let's go down to this one where we're talking about y equals the inverse sine of x. Okay? So the x, the input, okay, is no longer the angle, it is the sine ratio. And what we're trying to find is the what? The angle. Okay? We're trying to find the angle measure. Does that make sense? Okay, all right. Now, if you look in your books with me on page 320, I think you guys have a book. If you don't, grab one. It's worthwhile to see this. Okay? Turn to page 320 in your book. Okay, at the top of that page, page 320, it shows the graph of a sine function. Okay? It shows the graph of a sine function. And we all know that one period of a sine function looks like this, right? And if I continued it in the other direction, it would look like that, right? All right, so here's the deal. In mathematics, and you'll see this a lot in calculus, they talk about a one-to-one correspondence, okay? And I don't think this is anything that we've mentioned before. If a function is one-to-one, again, you're going to hear this in calculus. If a function is one-to-one, that means that not only is the function a function, but its inverse is also a function, okay? So to be one-to-one means that not only is the function a function, and of course the function is a function, or we couldn't call it a function, because it wouldn't be a function, so we couldn't call it a function. But not only is the function a function, but the inverse is also a function. Do you guys remember in Algebra 1 how you could just look at a graph and tell whether or not it's a function? We did the what? Vertical line test, right? And with the sine curve, which obviously we know it's a function, it passes the vertical line test. How could I know whether or not the sine curve whether its inverse is a function without graphing by giving a what? We gave a horizontal, I just gave it away. We gave a vertical line test to see whether or not this is a function, right? Yeah. If I just gave a horizontal line test, wouldn't that tell me whether its inverse is a function? Okay? So, to be one-to-one means that not only is the function a function, but its inverse is also a function. Does that make sense? Okay, now, your calculators, whether they're scientific or graphing calculators, computers, everything, all of these things that we use, they only work by functionality, meaning everything that we use is a function, okay? If it's not a function, then the calculator would just be like going, what are you talking about? Okay, a simple example would be like for me to say like in the quiz, if I use Will's student number as the input and then his grade on the quiz, 30 as the output. And I started doing that, and then in that same domain, if I would have said Will's student number again, and then said 2, that would be a problem, right? You'd be like, well, what do you mean? You said that Will got a 30, and now you just said that Will got a 2. Which is it, right? So the question is, that's not a function, because for every input, teachers do in the class, there must be a single unique output. Does that make sense? That's what makes a function a function. That's why vertical line test works. Like if Will was 3, and I said that he got this grade, and then later on I said 3, he got that grade, well then it wouldn't pass the vertical line test, right? Okay, so we want to be able to solve inverses, okay? But we know that the sine curve is not one-to-one. Its inverse would not be a function, and we need to make it a function, or we cannot use it on a calculator, graphic calculator, or anything, okay? So what we do is we are going, in order to preserve functionality, we are going to limit the domain of the function, okay? So if you look on the top, again, of page 320, you'll notice that they have the sine curve, but did you notice that they've kind of highlighted in part of it? Okay? What part is in dark? From what to what on the X? No, on the X. So right to left. Alejandra? That is the Y. Those are the Y's. What about on the X? From negative pi over 2 to pi over 2. Okay? So we have to limit the domain. Okay? It only goes from negative pi over 2 to pi over 2. And if we do that, okay, then does it pass the horizontal line test? You guys see that? So in order to preserve functionality, we limit the domain of the inverse function to just go from negative pi over 2 to pi over 2. Does that make sense? Okay? So let's write this down. So the inverse sine of an angle, or the arc sine, okay? The angle is limited. That is, its domain, or excuse me, it is limited. Okay, the angle measures are limited to go from negative pi over 2, okay, to pi over 2. So that's going to be like this. Okay, the angle measures have to range from negative pi over 2 to pi over 2. Okay? Now if you flip the page, go on to page 322, they have a graph of the cosine function. Okay? And then you'll see that there is a part of the cosine function that's highlighted. Where does it go from? From 0 to pi. Okay? And if you look at that graph, if the domain is, if it's limited from 0 to pi, then it preserves functionality, right? You could do the horizontal line test and it would work. Does that make sense? Yeah, see that on there? Okay? So let me choose a different color here. All right. So the inverse cosine ratio, or the arc cosine, all right, its angle measures are going to be greater than 0, greater than or equal to 0, and less than or equal to pi. Okay? And again, that's in order to preserve functionality. We have to limit the domain so that its inverse is also a function. Does that make sense? Okay. All right. Last one. Inverse tangent or arc tangent. Okay. So let's just look at let's go over here real quick, and I'm just going to Widmopoy. Like, what does one period of the tangent function look like? So we know it goes from negative pi over 2 to pi over 2, and it looks like this, right? So one period of the tangent function, if I just graph one period, doesn't pass horizontal line test. It does, right? So if I just say, okay, well, the angle measures for the inverse tangent function, okay, in order to preserve functionality, they too are going to go from negative pi over 2 to pi over 2. Okay, does that make sense? Sarah? So if you look at the Widmopoy for that on the top of page 326, you see that, like, for example, if we would have ran that, let's look at this real quick. So we know, that the cosine curve starts here and it does this, right? Okay? And if I were to carry on over here, it does that. If I ran it from negative pi over 2 to pi over 2, just like we did with the other two, it would not pass the horizontal line test. So if I restrict its domain to here, okay, that's going from 0 to pi, and it passes. That's why. Okay? All right, so I wanted to take some time to kind of explain to you why this is true, so you understand the why behind it. Okay? But here's the nuts and bolts. Like, this is what you've got to know. Okay? This is what we have to know. So we're talking about inverse functions. Okay? So we know that the sine and the tangent. So the sine and the inverse tangent function. Okay? So the inverse sine, okay, and also the inverse tangent. Those functions are defined from negative pi over 2 to pi over 2. And again, the reason for that is because we have to preserve functionality of the inverse function. Okay? The cosine, the inverse cosine, goes from 0 to pi. Okay? Should I write those out over here? That may be advantageous. Okay, so we have that on the other page. The way I remember this is I just think of inverse functions are defined from negative pi over 2 to pi over 2. The cosine is the one that's out there by itself. It goes from 0 to pi. The other two go from negative pi over 2 to pi over 2.
Why is the graph running from pi to 0?
So the cosine, inverse cosine, goes from 0 to pi. Okay? The other two go from negative pi over 2 to pi over 2. Does that answer your question?
I was just wondering, like, 0 was on the right and why is pi is on the left here?
Because this wouldn't this be 0 radians? pi radians?
I did it.
Okay? Alright, I'll tell you what, so we're gonna start busting out some of these questions. If you guys, you're gonna wanna get your unit circle, like, it's gotta become like your best friend again, okay? So if it's not, it may be advantageous for right now, today, to bust that out from your notes. Not the one, we did 2 unit circles. We want the one that actually says unit circle on it. You may wanna take that out of your notes. Once somebody comes up with it, I'll hold it up. So this is the first one we did, but there was one we did after this that actually says unit circle on the top of it. That's the one you want. Because this one is the one that has ordered pairs written on it, and you've got to get it to where those are like right up here again, where you can just bust them out like that. Okay, so, all right. So we're going to kind of bust through these together. I'm going to start us out with one of these, and then I'm going to give you guys time to try to figure some of these out on your own.
This is from our homework.
What's that?
This is our homework.
This will be, this is not, first of all,
Oh,
we don't use that dreadful word. But is this your homework? No. No, I'm just, we're going to do some examples. Okay. All right. So, with that? You go ahead. What?
When was it that you decided to start using the word investment rather than the other?
Oh, I think it was when I had a student teacher. I had a student teacher, and it just started dawning on me that I started using that word with her. I think it was in fall. Yeah. Yeah. Another key word like that I realized is that try to engage students all the time. Like right now we're going to do this, and I could just sit up here and then just do every question for you, and just say, you understand? Okay, but once I think that you have a clue, I'm going to try to engage your mind to use what you just learned to see if you can do it on your own rather than me just being up here going, okay, here's the next thing that you must do. So here we go. So I'm going to think out loud, all right? Listen like a champ. If there's something that I say that doesn't make sense, Peter, then ask. Okay, so here we go. Arc cosine. Okay, so we're trying to find an angle, right? We're trying to find an angle. We know that arc cosine is defined from 0 to pi, correct? Okay? So that means I know that this thing is going to be in the first or second quadrant. Okay? Arc cosine or inverse cosine is positive, right? What quadrant must it be in that it's positive? The first quadrant, okay? So inverse cosine is defined from 0 to pi. The ratio, radical 2/2, is positive, so it must be in this quadrant, okay? So now, in my little brain, I say, okay, on my unit circle, when is the cosine, that is, the x-coordinate, radical 3/2, or excuse me, radical 2/2, at a 45-degree angle, or in radians, pi/4, so that is in fact the solution. Shut. Next. So cosine is the x-coordinate. So if you've got your, right, on your unit circle right there, so cosine is just whatever the x-coordinate is on your unit circle. Because cosine is x over r, and r is 1. Okay, so that tells us where, that's going to tell us where what quadrant it is, like where it's in. It's going to go from 0 to pi. All right, let's do another one. Let's do another one together, and then, so I'm just thinking out loud, okay? Okay, yeah, so here we go. Let's try another. So inverse cosine, okay? So my first question is, if this is inverse cosine, I'm saying, well, when is, in order to preserve functionality, when is inverse cosine defined? It's defined from 0 to pi. Everybody good with that? Alejandro, does that make sense? Okay? Renee? Okay. So I know that angle is going to be somewhere from 0 to pi. Okay? All right, now I go to my unit circle. All right? We know that cosine is x over r, and if it's a unit circle, well, then we know r is 1. So really, negative 1 is just when is, from 0 to pi, when is the x coordinate negative 1? At pi. So here's my unit circle. When is the x coordinate negative 1? Right there. What is that? That's pi. So when is the inverse cosine negative 1? At pi. Does that make sense?
Yeah.
Okay. There. Yeah, because we were speaking the language of radians. It's not wrong. It's just we will default to radians. Okay? All right. So here we go. Arc tangent is 0. I'm going to give you guys a chance to try to bust this one out on your own. If you get this, in my humble opinion, you scream radians. Let's all attempt to do it on your own first. Remember, inverse tangent is only defined from negative pi over 2 to pi over 2. From negative pi over 2 to pi over 2. All right. Taking answers. Anyone think they got it? Anyone feeling confident? Gracie, what did you get? Oh, I thought you were giving me a yes. Emily, what did you get? Just say it. No big deal. 0. What did you get? 0. Ooh, there's a pattern here. Anybody else want to jump on board? 0. So this highway. How many of you guys got 0 for an answer? All right, almost half of it. So here we go. So you guys get this, right? Inverse tangent only defined from negative pi over 2 to pi over 2. Okay? This is the ratio right here, right? That's a ratio. We're trying to find the angle measure. So if it's 0, isn't tangent y over x? And the only way we're going to get 0 is if the y is 0. Right? Okay? Because 0 divided by anything is 0. It's only defined from negative pi over 2 to pi over 2. And y is 0 either here or here. Right? 1, 0, negative 1, 0. But is this angle even defined for inverse tangent? No. So it is, in fact, 0 radians or 0 degrees. Okay? All right. Try the next one on your own. Okay, I'll tell you what. If you correctly answer this next question, I will pause this recording, drop, and give 20 push-ups. No one this morning correctly answered this. This is pause. Oh, I get it. Okay, so inverse tangent is only defined from negative pi over 2 to pi over 2. So it's defined over this range. Okay? Tangent, we know, is y over x. The only way we're going to get a 1 or a negative 1 ratio, y over x, is if they're the same. That's radical 2 over 2, radical 2 over 2. That is a pi over 4 reference angle, right? You with me? Pi over 4 reference angle is negative. That happens right here. Okay? So a good wrong answer would be to say 7 pi over 4, because that is a coterminal answer to the solution. But since it's only defined from negative pi over 2 to pi over 2, the correct answer is in fact negative pi over 4. Does that make sense? Okay? Yeah. There were a handful of people that said 7 pi over 4 earlier today too. Because a pi over the first positive like this coterminal angle to that would be 7 pi over 4, because that's pi over 4 away from 2 pi, right? But the inverse tangent curve is only defined from negative pi over 2 to pi over 2. Does that make sense? Okay, all right, we're on a roll. I think you guys are going to start like, Will, we didn't get it. Well, you got it, but you weren't getting it.
I low-key got it.
Okay. All right, if I think it's worthy, if there's another one that I think is, but I do think we have to, Will has done this before, so this is not needed. Okay, go ahead and start the first one. Try to bust that out. We're going to do 4 more of these. Okay, try that first one. Actually, we're going to try all of them, but we'll do them one at a time.
Pause to do work.
Okay, so if you're busting this out at home, just go ahead and pause it, try to bust this out, and then turn it back on when you think you got it. All right, I think I gave you guys enough time for the first one, right?
Yeah.
All right, what do we get? Liz, what did you get for the first one?
I was talking to you about whether or not you should have it.
Okay, Emily?
Pi over 6.
Pi over 6 is correct. Raise your hand if you got pi over 6 for the first. Okay, so a little over half. So if you didn't get that, then listen to this explanation. If you did, then move on to the next. Okay? So we know arc cosine is defined from 0 to pi. Okay? It's going to be either in the first or second quadrant. Cosine ratio is positive, which puts it in the what quadrant? First quadrant. So here it is. If this were a unit circle, we're just basically saying when is the cosine, the x coordinate, radical 3 over 2, and you either know the unit circle in your head, or you're looking at it right in front of you, and that happens at pi over 6, when the x coordinate is radical 3 over 2. Okay, if you're listening at home, I'm going to pause again, just so that people have a chance to do the next question. Okay, we're on. What do we get? Pardon? 2 pi over 3. Any other answers? Somebody agree with that? I don't know what the answer is. 1, 2. Ooh, looks like 2 pi over 3. Let's see how don't you got, Will? Well? Okay. Inverse cosine. So you guys can start to hear me say the same thing. So hopefully that's a good thing. Inverse cosine, we know, is defined from 0 to pi. It is negative, which is going to stick it in what quadrant? Second quadrant. So I know it's going to be over here somewhere. Then I bust out my unit circle, because that's what I do, is I bust out unit circle. And I say, when is the cosine, the x coordinate, negative 0.5 or negative 1/2? That happens at what reference angle? A 60-degree or pi over 3 reference angle. So if it's a pi over 3 reference angle in the second quadrant, that is in fact 2 pi over 3. Giddy up. Giddy up. Very good. You guys are busting these out. All right. Try the next. Okay? If you're listening at home, I'm going to pause to give people a chance to do this on their own. All right. So real quick. Pi over 4 And if you guys recall, radical 3 over 2, remember I told you on your unit circle to remember that the tangent of a 30-degree angle is radical 3 over 3. Tangent of a 60-degree angle is radical 3. So hopefully you recognize radical 3 over 3. That happens at a pi over 6 reference angle. So pi over 6. Giddy up. Assignment page 327, 1 through 9, 13 through 20. Good day.